is today's presenter. His name is Kevin, and his topic is I don't know exactly about the engineer of the steel. Yes, what many mechanical engineer do in steel work. Okay, let's start. Let's welcome him with a full applause, please.
Yeah, thank you. And from now, I will start my presentation about the title is What Mechanical Engineers Do in Steelworks. And I ready some special case about increasing the capacity of ladle. Just right before I came to this MBA, I do kind of making a strategy and kind of human resource because our sector we have 2,000 people in our sector, so I will do that kind of things. But when I was a freshman in the company, I used to do these kind of the technical things. So I'm ready for you guys. This is the contents. I will yeah, introduce what is the background, and but I will do not as a technical, just show you the concept of what I did. Yeah, it is very easy. Nowadays, demands for the stainless is increased, so we have to increase our productivity. So that is the reason, and this is very famous. Walt Disney concert hall is made by the stainless. So you can see that it's a process of the stainless making process, and EAF means the electronic arc furnace. So we can melting the steel in here, and the AOD was a neck point of this process. So I have to figure out, how to increase the productivity. And maybe you can see this moving ladle.
Oh,
Yeah.
Oh,
Yeah, and maybe you can imagine this ladle carry the molten steel, kind of the water, and it is like a lava. You know, the volcanoes came from the lava, so it looks like the red one, and it's the real picture of the ladle. So you can imagine the size. And the shape of the charging ladle is composed of shell and castable inside, and we have the molten steel. So it density is 6.8, so it is very it's more bigger than water, so you can imagine. So the increase method was just very simple. Increase the 200 millimeters, and because of the height, we can get more 10 tons for every ladle charge. So if we have designed this thing, we have to figure out it is safe or not. So can anybody guess 4 review points to use this as an engineer? I will skip. First, I have to check the stability because I'm ready for this as a ladle. If I have to raise this height, I have to check this stability is okay or not. So, because if the turning axis is under the center of the gravity, it can pour out anywhere. So it is very important to check the stability. So it was okay. And the second point was the strength of the ladle shell, because the weight of the steel is getting high, and also this molten steel has a static pressure to pushing outwards to the shell. So I have to figure out if the shell is okay. And as you can see, there are very high temperatures, so I have to consider the temperature to the allowable stress. So finally, it says it was okay. I did this kind of things by computer, the structural analysis, 3D program, and it was okay. And the third one is the capacity of the hoisting rod, because the weight is getting high. We have to figure out this kind of the tilting device is okay. And the last point is to check the safety of the tilting device components. As you can see the picture, this is the main hoist, and the second hoist is using this part as a tilting device. So we have to figure out these parts are okay. So every rod pin plate are safe. So as a result, I said we can increase the height, and actually this technical review is adapt to the real level, so it affects every day. We can produce more than 200 tons, and also not only the stainless, but also we can apply to other vessels. So it was, yeah, it was my technical review, and this is the end of my presentation.
Very good.
Thank you very much. If you have any question, please ask very freely. This is what I did for analysis.
Did you calculate or did you analysis of the like the gravity or some of the like the problem?
Yeah,
Did you really?
normally I calculate by my hand, and also we have to check by the computer. So if the how can I? The answer is the same, we can say it is okay. So yeah, we have
Calculate in your hands?
a very
Oh, really?
simplified. So,
Oh, really?
yeah.
Wow.
Actually, I don't know what to understand.
Oh, really?
And all I understand is the height and the 양동이 thing, frozen 양동이 is going higher.
Yeah, that's my conclusion.
Yeah, and then the production increase.
Yeah.
And it's good. Postco likes it, and you're a good engineer.
Yeah, thank you very much.
Yeah.
That is a key point.
Yeah. All I understand is that. Wow.
Yeah, this is a real factory picture. So I work for like kind of this condition.
Oh,
Yeah.
How many rattles do your factory have?
Maybe over than 100.
100?
Yeah. Because we have 45 factories in Pohang, and maybe not all, but around 10 factories use this ladle. So every factory, they have more than 10 ladles. So I can assume maybe over 100
rattles.
Yeah.
So this rattle always boiling the steel every day?
Boiling is in the furnace, arc
Yeah.
furnace, and the ladle is kind of the translator to
Uh-huh.
the next step. Yeah.
Okay, to make a certain shape.
Yeah, that's right. And a certain shape came from the continuous casting. It is the way to mold. How can I? To make a hard steel.
Oh, okay.
Yeah, on by the CC, and we can say have this slab.
So every factory every day
Mhm.
making steel, that kind of process every day.
Yeah, of course. Because we can, if we have a break, the molten steel is getting hard in here, so we have to broke whole the facility if the molten steel is not a molten. Molten means
Okay.
kind of like a liquid. It can turn out to the rigid, solid.
Yeah.
Yeah, so
Mm.
we have to watch all the days.
So whole kind of process working every day.
Yeah. But
If there are stuff, there will be problem.
yeah, that's right. That's right. So the maintenance department is very important in steelworks.
Oh, okay. Thank you. Then you don't have any holiday.
Yeah, that's right. We have shift workers
Yeah.
from the site, and if there are a big problem from the site, they call us to figure out what's problem, and I have to go and to fix or to figure out what's the problem. And
This is 24-hour process.
yeah, that's right.
Oh, okay. Thank you.
24 hours for they are 3 shifts, so every
Okay.
8 hours. Yeah, that's right. Okay, if you don't have any question, I will finish my presentation. Thank you very much.
Thank you.
그
이거 옛날에 무슨 그 저 뭐야 발표할 때 썼던 그런 자료인 것 같은데
맞아요.
너무 퀄리티가 좋은데 이걸 위해 만든 것 같진 않은데
누구 대학생들 견학 오면 설명해 주셨는데
그러니까 약간 요거 그런 느낌.
그러면 잘
뭐
만들었네.
발표 자료 같은 거여서 그냥
그러니까
네, 맞아요. 이렇게까지 안 하죠 사실.
네, 신기하다. 근데
이거
그 계산하는 건 뭐 어떻게 계산하는 거야? 뭐로 계산해? 그거 어떻게 계산하지 근데?
이렇게
프로그램이 있지 않을까?
네,
프로그램으로 하는 거. 손으로 한다고 막
단순하게 이렇게 할 수도 있고 단순화해서 해야 되는 게 키포인트긴 한데.
단순하다.
네.
그러면 이게 막 원래는 100톤이었는데 110톤이 되면 무게 중심이 여기에서 요만큼 떨어진다는 걸 손으로 계산할 수가 있어. 그런
그런
공식 같은 게 있어? 아 그래?
어떻게 알아듣지?
We are all
양동이를 아까
engineers.
들었어. 양동이를. 야 내가 영어 알아들으면 야 놀랄 일이야.
아니 영어가 아니라 영어로 하는 과학이잖아요.
야
네,
그림 보고 유추했어.
아
영어를 못해서 내가.
그렇구나.
그런 문제가 있겠지.
이거 해야 되는 건가요? 그
녹화 전에?
Evaluate.
evaluate.
나야.
We have to speak in English.
It was me. Anyway, thank you for Kevin's presentation. He interestingly solved the rather difficult subject of steel. Difficult word appeared, but he explained it very well. There are many paintings, pictures, so we got easy to understand. Thank you for Kevin making a good presentation. Thank you.
Yeah, thank you very much about hearing.